Hey everyone, Mr. Fugay here, and in this video we're going to talk about part 2 of your Rotten Tomato project, where we're going to take our movie data, which we created a box and whisker with, and we're now going to create a scatter plot with it, and a line of best fit. Both of these we are going to use the Desmos online calculator to help us complete. So we're going to walk through my example in which I took 10 movies with Adam Sandler and jotted down the tomato meter score, which is the critic score, and the audience score as well. So let's start with Desmos. For step 5 of this activity, we're starting step 5 because the first 4 were part of part 1. We are going to create a scatter plot on Desmos with our movie data that we used in part 1. So we're going to go to desmos.com/calculator. We're going to press Graphing Calculator. And over here on the left-hand side, we're going to go ahead and create a table. So I'm going to press the plus button. We're going to hit Insert Table. And it's going to create a table here, X1 and Y1. Now, your tomato meter score should be your X column, and your audience score should be Y. So for example, the first movie I have here is Billy Madison, which got a tomato meter score of a 41 and an audience score of a 79. I'm going to repeat this process for Happy Gilmore, which had a tomato meter score of 61 and an audience score of 85. I'm going to go ahead and just quickly type in these other numbers, and feel free to fast forward through this portion if you need to. It will just take me a moment. Let's see, 31, 62. So just again, tomato meter score each movie. You're going one movie at a time. And I have 2 more to do. And we're done. Now, if you look over here on our graph, you'll see that we don't see anything. And part of the reason that is because look at the numbers in my table. They're all in the 40s, 50s, 60s, and 70s. So if I zoom out, okay? So if I zoom out, which you can zoom out by pinching, or you can use your mouse or trackpad, we'll see that if I start to zoom out enough, we will end up finding, oh, there's our data right up there, okay? So what I have here now is my scatter plot data. There it is. And I want to take a snip of this. So we're going to use the snipping tool to take a quick screenshot of this. There are many ways to do it. The way I'm most familiar with is I press the search button, and I'm going to type snipping tool. We're going to click on it. I'm going to press new, and the screen is going to gray out. I'm going to click and highlight to create my graph. And I now can, don't worry about those red dotted lines on the screen. I think that might be because of my screencast. But we're going to go ahead and hit Edit. Come back over here under number 5, and I'm going to right click and paste. And there is my scatter plot for my 10 Adam Sandler movies. Okay? The second big part of this video, or the second big part of this tutorial, I should say, is that we are going to also create a line of best fit. So to do that, we're going to go right back to our data, right over here. And I'm now going to go to a fresh new line underneath here. And to create a line of best fit, since this is going to be a linear equation, we want it to be in the form y equals mx plus b. So to do that, we're going to type in not y, but y1. And the reason why I'm doing that is because I want to pull the data up here and try to use these 10 numbers as my y values. Instead of pressing equal, we're going to press the shift and then the tilde button, which is located next to the 1 on your keyboard, right underneath the escape key. So press shift and then that button. And now we're going to type in mx plus b, but when I type in x, I have to use x1 like it's mentioned up here. So mx1 plus b. And so this black line that's up on my screen is now a calculation for my line of best fit. Some of the key numbers that we need to pull away from this is the R value, which is right here. That's going to tell me how good of a correlation this is. Since R is positive, that means it's a positive correlation. And the number 0.81 tells me that it's a pretty good approximation considering 1 is perfect and 0 is the worst. So it's kind of like getting a B. Getting a B is not bad, so it's pretty decent. I also was giving my M value and my B value. So the next step here we got to do is we got to first take a quick screenshot of our new line of best fit. So we're going to go back to our snipping tool, press new. I'm going to go ahead and click and drag to create my graph. And I'm going to go back over here to my work, and under number 6, I'm going to paste my picture, and I'll just go ahead and make it a little smaller so it's not taking up the whole screen. We do need to come up with the equation here, And the way that you're going to come up with your equation is we're going to look at this data right here. So I'm going to take a quick screenshot of this and use this to help illustrate some of the different things we're doing. So give me just 1 second to fix something. Okay, so now that I have that data, what I need to do is to write an equation using this information. So normally an equation is written in the form y equals mx plus b. Now in this problem, my m is 0.42. So we're going to round to the nearest tenth, and in my example, my slope is actually going to be 0.4. My b value is right here, and to find my b value, that is going to be a 53.9, so I'm going to go ahead and round it just to be a 54 from there. So there's the equation of my line of best fit. We'll need to use that in some of our questions moving forward. So at this point in the video, if that's all you needed, you can stop and try this out yourself. I'm going to take the next few minutes of this video and talk a little bit about some of the analysis questions that we need to use below. So starting with number 7, I'm going to have my data right here to help answer our question. It says, what observations and analysis can you provide from this data? What I want you to talk about here is what is the correlation of this data, and what does this correlation tell you about the tomato meter and audience score? So when I'm looking at that, the biggest indicator for this is the picture. And the picture can show that it is a positive trend line. It's moving upwards. So this, to me, looks like a positive correlation for this data. Another reason that this would justify is my R value. Whoops, something just happened there. My R value is positive. And when R is positive, this means it is a positive correlation. So you want to use that information and your knowledge of correlation to try to create a couple sentences to explain what's going on. Moving into number 8, the next question I ask says, do you feel that the line of best fit is a good predictor for the tomato meter scores and the audience score? As I said before, if the line of best fit is a good predictor, this has everything to do with the R value. Everything to do with the R value. In fact, if we go back to our notes on correlation, here's a nice little chart that helps us out to figure out what we're looking at. My R value was 0.84, I think. So which means, to me, this would be a strong positive correlation. It means that the correlation is pretty decent. It has a positive trend to it, but it's not exactly a straight line. So that's what we're going to go with in my analysis for this next part. And in the final part of this, number 9, we're going to talk about using the line of best fit to predict scores. So, for example, we know that X is going to be our tomato meter score, and we know that Y is going to be our audience score based on the way the scatter plot was created. If a movie's tomato meter score is 65, what would the estimated audience score be? So to answer this first part of the question, remember that the equation we came up with just a few moments ago was y equals 0.4x plus 54. So since I know that my tomato meter score is 65, I'm going to put that in for my x. So I'm going to have y equals 0.4, and so instead of writing x, what I'm going to put in its place here is I'm going to put a 65. We're then going to go ahead and calculate this and come up with a solution. So in my calculator, all I would have to do is type in 0.4 times 65. Oops, I'm doing that on my own here. So 0.4 times 65 plus 54, and I'm going to get an answer of 80. So what this tells me is that if a tomato meter score for an Adam Sandler movie is 65, then we're going to predict that the audience score for this is going to be an 80. So we basically created a formula for this. In fact, if we actually look at the Adam Sandler data, I have some numbers that are pretty close to this. For example, Happy Gilmore, the tomato meter score was a 61, and the audience score was an 85. So this is roughly about correct, all right? Tomato meter scores that are in the low 60s will end up being in the low to mid 80s based on this correlation, okay? And for the final one, if a movie's audience score is 45, we want to estimate the tomato meter score. So if the audience score is 45, this is my y value. My equation, once again, was 0.4x plus 54. I'm going to plug in 45 for y. So I get this right here, 45 equals 0.4x plus 54. we're now going to solve for x. So I'm going to subtract by 54 on both sides first. Something strange is going to happen for my example. This may not happen with yours, but I will explain what's happening as I'm solving this. Because when I divide both sides by 0.4, let me go a quick calculation. Negative 9 divided by 0.4 is going to give me negative 22.5. So this is interesting because one of the reflections here I want to get is, how could a tomato meter score be negative? Because it's a percentage. And the answer to that question is, well, we have to actually go back to the original data and recognize something. If an Adam Sandler movie had a critics or tomato meter score of a 0, the audience would still give that score, still give that movie, on average, a 54 rating. So a really, really bad movie, according to the critics, the audience really likes Adam Sandler this much that they would still give the movie a 54 out of 100. So going back to that question, if an audience scores 45, well, the line of best fit pretty much is telling me that this is actually not possible. So the line of best fit is saying that the audience would never give Adam Sandler a score of 45 based on our line of best fit. Now, how valid is that? That's a whole nother topic and a whole nother conversation. But for now, that's where we're going to leave it. Feel free to pause this video and go back to any other portions of it to rewatch it. But try this now with your movie data, and let's find out what you learn about the movies you chose. Thanks for watching.